In this lecture we shall construct by way of example a proof involving a mapping and the notion of image. Let A and B be sets, and let F be a mapping from A to B, and let S and T be subsets of A. Our goal will be to prove that the difference of the image under F of S and the image under F of T is a subset of the image under F of the difference of S and T. Let's first construct a derivation and then transform it into a proof. The main symbol of the formula to prove is the subset symbol. So we apply the definition of subset. It states that in order to establish a subset relation, we should establish a universal quantification. Thus, we declare an element in the left-hand side set and state as our new goal to prove that it is an element of the right-hand side set. We deliberately use y as the name of the declared variable to remind ourselves that it stands for an element in the codomain of F. We can further simplify our goal. Note that it involves the image of the difference of S and T under F. We can apply the property of image that states that to prove that y is an element of the image of some set under a mapping, it suffices to show that there exists an element x in that set that is mapped to y. Our goal is now to establish an existential quantification. This is usually a good moment to switch to forward reasoning mode. Perhaps a witness will naturally present itself. It is convenient to picture the situation. We have an arbitrary mapping, F from A to B. We have two subsets S and T of A, and their images under F as subsets of B. Both the difference of S and T in A and the difference of the image under F of S and the image under F of T are colored blue. Furthermore, we have declared y as an element of the difference of the image of S and the image of T, both under F. And our goal is to find some element in the difference of S and T that F maps to y. We proceed to draw some conclusions from the assumption about y. With the property of difference, we find that y is in the image of S under F, but not in the image of T under F. Let's focus on the first conjunct, stating that y is in the image of S under F. We can apply the property of image to it to conclude that there exists an x in S that F maps to y. The witness we get for the existential quantification in line 4 may actually turn out to be the witness we also need for the existential quantification we wish to establish. We have an x such that f of x equals y, but note that we are not there yet. Our goal existential quantification needs x to be in the difference of S and T. And so far, we only know that x is in S. We have deliberately drawn x at the border of T to suggest that it may actually still be an element of T, and hence not in the difference of S and T. So we still need to prove that x is not in T, and we shall see that this can be derived from the fact that y is not in the image of T under F. Now that we have a candidate witness, we can do some backward reasoning again. Since we already know that F maps x to y, it suffices to establish that x is in the difference of S and T. The goal can be simplified with an application of the property of difference. That x is an element of S is already part of the declaration of x. So it remains to establish that x is not in T. According to our standard method for proving a negation, this amounts to deriving a contradiction from the assumption that x is in T. Consider the assumption that x is in T. Since f maps x to y and y is not in the image of T under F, we get a contradiction if we show that f maps x into the image of T under F. By the property of image, we may conclude from x in T that f of x is in the image of T under F. Combining that f of x is in the image of T under F, and that f of x equals y, we may conclude that y is in the image of T under F. This contradicts the formula on line 6, which is still valid. And thus, we have derived the required contradiction. Thereby, we have now established that x is not in T, allowing the conclusion that indeed x is in the difference of s and t. Our formal derivation of the formula is now complete. Let's now transform it into a more readable proof. When doing so, we shall indicate the correspondence between the derivation and the proof, and moreover use our color scheme to highlight the different roles of statements in the proof. You may want to refer to the introductory lecture on flag-style derivations for an explanation of the color scheme. First, it is good practice to state what will be proved. So we declare sets A and B, a mapping F from A to B, and subsets S and T of the domain of F, and then state as our main goal to prove that the difference of the images under F of S and T is a subset of the image under F of the difference of S and T. The proof starts in backward reasoning mode to simplify the main goal. We apply the definition of subset, which gives rise to the declaration of a y in the difference of the images under F of S and T. The simplified goal is to prove that this y is then also in the image under F of the difference of S and T. A further simplification, using the property of image, yields that we need to prove the existence of some x in the difference of S and T, such that f of x equals y. Then we switch to forward reasoning mode. We apply the property of difference to the assumption that y is in the difference of the images under F of S and T to find that y is in the image under F of S and not in the image under F of T. Since y is in the image under F of S, we may conclude with the property of image that there exists x in S such that f of x equals y. We proceed with some backward reasoning again. In a proof in natural language, it is, for readability, sometimes a good idea to recall what is the goal to be proved. With the application of the property of difference, using that we already have x in S and fx is equal to y, the goal can be simplified to showing that x is not in T. Note how, again for readability, it is recalled that f of x equals y and x is in S are already established facts, needed here for the simplification of the goal. To prove that x is not in T, we assume that it is in T, and set out to prove a contradiction. The proof can now be concluded in forward reasoning mode. Using the property of image, we may conclude that f of x is in the image under F of T. And then, since f of x equals y, we find that y is in the image of T under F. We conclude that we have arrived at two contradictory statements, as was our goal. We have now established the property we set out to prove at the beginning of this lecture. This concludes our discussion of an example proof that involves a mapping and the two properties of image.